Hi, everyone. It is lovely to be here. My name is Anita Schjøll Brede. I'm the CEO and co-founder at Iris.ai. And for the next 18 minutes or so, I'm going to be talking about artificial intelligence and specifically how we apply it in preparation for testing new formulations. And I'll talk about what we mean with that as well. And we're going to go more into details into one of our most recent innovations and breakthroughs, which is all about data extraction, for example, of the experiment data that other people have published through papers or patents. But in short, why it is that we do what we do is that human beings are absolutely brilliant. There is such an abundance of things that we humans are really, really, really good at. And unfortunately, large-scale literature reviews and extracting data from patents and documents is simply not one of them. It's a process that is error-prone, time-consuming, tedious. And so we decided to do something with that so that we can give human beings time to be good at what they're good at and have machines do what human beings are both not good at and also quickly get really bored with and make a lot of mistakes in. So briefly about us, we've spent the last 5 years building an award-winning AI engine for scientific text understanding. And what that means is a core engine that can understand and navigate and make sense of scientific text. And I'll get a little bit more into the tech later, although keeping it fairly simple for this short presentation. And with award-winning, I mean that we're actually semi-finalists in the AI X Prize. So our technology has been thoroughly vetted, both on the technology side itself and the contributions to the field, but also on its applications on scientific text. Now, this core engine is trained on a general scientific corpus, but it is domain aware within chemistry, meaning it understands chemistry better than any other field. And it can also be reinforced on a specific client or user's domain, meaning if you're working with a specific set of polymers or, specifically within pharmaceuticals, there's a niche field you're working with, the engine can be very, very easily trained on that domain, which makes all of the difference when it comes to applying machine learning model, in a more general way. And with general, I mean within science, of course. We are a niche player, but general within that field. All right, so what we've spent the last 5 years building is actually kind of a full modular suite for literature reviews. And it's beyond the scope of what I can talk about today, kind of the full scope of what we're doing. But in short, we have modules that allows you to, bypass the need for keyword searches by matching a description of your problem to literature at large and fetch the information you need. We have a variety of really smart AI-based filters, such as dynamic document evaluation, and even kind of advanced literature list refinement, where you can build your literature, your precise literature list based on a combination of entity tracking, which is more similar to keywords, and contextual understanding. So you can simply describe the context that you need the paper to be about. Let's say a specific type of disease or a specific intended use of your medical device or your drug or your chemical. Then we also do a number of things like highlighting relevant information, summarizing group of documents, and all of this can be automated and run on a regular basis if you do, pharmacovigilance or you do other post-market surveillance. But what I really want to dig into more in detail today is module F, as you can see here, which is extraction of key data points. And what do we mean with that? Well, we mean that in a variety of PDF documents, whether it's patents or papers, depending on what field you're working with, there is going to be tables and text that has a plethora of data that, depending on what you do and depending on who you compete with, whether you're in academia or in industry, the chances are high that you're going to want your competitors or your collaborators' data, but you don't have it readily available in an Excel sheet, because again, it's going to be published in a PDF document somewhere. And the data is all there. You can extract it manually. It just takes a lot of time. And remember, I talked about earlier with, this tool being applicable in a variety of different fields. We've worked within the steel industry, where the company very specifically wanted to extract experiment data so that they knew what their competitors were up to before they themselves would go into the lab. We've been working in agri-tech with implicit chemical formulas, where we actually are right now learning to extract chemical formulas like the pictures and connect that to the text and the descriptions. And then we're also working with research groups, for example, within drug repurposing, where the data needed is things like properties and adverse effects. So really what we've been able to build is a tool that can work with data from a variety of different disciplines and fields. What they all have in common is that this is data in tables, in text, in images that needs extracting into a database or an Excel sheet where you can very easily access it. So here is, one example of how this would usually look like, right? And I'm sure everyone on this call has been there. You have a piece of text, that you have to make sense of what the text is referring to, which table, what numbers in which table, etc. And it's just a never-ending task. And in fact, this specific client told us that in order to go into the lab and do their work properly, they have to extract the data from about 100 to 200 patents, and they get through 60 patents per person month. So this is incredibly time consuming and error prone, which is why we built the extract tool for them and others. And in short, the researcher or reviewer's work radically changes. As you can see here, all you do is drop in one or multiple documents into a folder, or however the tool is set up. It's a drag and drop, boom, and then the magic happens. That is all the human now has to do, plus potentially reviewing the results afterwards if wanted. So what the tool does is going to be very similar to what the human needs to do if done manually. So we start by extracting entities and data from the text. That means we recognize all of the processes, all of the products, all of the chemical names, compounds, etc., from the text, and of course the corresponding data and units. Then we extract data from the tables, and we use machine vision to go in and find the tables themselves first, then we find the rows and the columns and extract all the data. And both of these tasks are, if you know what you're doing within machine learning, it's not terribly complicated, although we have an advantage because we've been working at it for 5 years. Now, the next thing we do is where the real magic lies, which is linking and matching all of the data points found to all of the entities described in the text to what we call the output data layout. And the output data layout is going to be defined by the user, saying, here is the data I need, and defining that in headers where it simply says, here's the, let's say here's all the the chemical elements that we're looking for. Here's all the products, here's the processes, here's the properties we're looking for, and all of that then being listed in these columns. And then so what the tool does is when it's fetched all the data points, matched it to the entities in the text, it matches it to your columns to place the right information that you were looking for in the right locations with the units you want. And I'll show you an example to be more concrete. So here is a patent from the European Patent Office. It's all about high strength cold rolled steel sheets and how to produce those. And for reference, for those who are not familiar with material science, in this patent, we're going to find a list of different steel types with their chemical composition. And then the author is going to have run a series of experiments. We're going to have 10, 20, 30, 40 different experiments on each of these different steel types. We're going to have steel A, B, C, D, E, experiment A1, A2, A3, etc. So done on on steel A. And what you can see here is that we have this front page, then we have 22 pages, as you can see in the top right, 22 pages of text describing the steels in the experiment. And then we have 25 tables of both the steel's composition and all of the properties after it's gone through all the different processes. So it's quite a complicated patent. And this is the one where it will take at least half a day to go through this full thing to extract the data needed. Now, so after this is submitted to the tool then goes, as I said, takes out all the entities, all the units, finds the tables, and links it all together and puts it into this output data layout that is produced. So here we can see all these different 18 types of steel that this patent had, where you can see the chemical composition of each of them. So you can see, the amount of carbon and silicone, etc., which is all fetched from one table in the patent. So that's fairly straightforward. What the tool, one important thing to note is that the tool won't actually know how many steel types is in a patent. So you can run, 1,000 patents through, and the tool will simply find all of the steel types or all of whatever types of data you're looking for. However many they are, the tool will recognize that and fetch it. What the tool will also do then is recognize each experiment as a line item, and each experiment in this patent has data from multiple tables. As you might be able to see here on the screen, we have table 10, 14, 18, etc. And the tool actually combines all that data into one row and lists all of the processes done to it, all of the, the properties afterwards, the microstructure post-experiments, etc. So all of that data for each single experiment, and again, fetched from multiple tables, is put together. The tool also handles things like when something is described in the text. So maybe there is, I know for this patent, somewhere in the text it describes how all of these sheets were prepared by taking a steel slab and going through a hot rolling process. And the tool is going to recognize the fact that this is a description of all of the steel sheets that we start with. So that data is going to go in, how they all were prepared to begin with. There's also, we handle things like legends. So if there's a description somewhere of a table, we're going to be able to relate what that description says about the headers, for example. We handle multiple units. So everything is converted into the unit you want. We handle abbreviations. There's also a column that's going to give you any additional information. So if there's any data point you didn't know you needed, but that is very similar to what you've already requested, you're going to get that. And finally, what you're going to also get with a tool, which is very, very important, is a confidence score for both the overall document, each overall document, but also for each extracted item, meaning you can very easily go into this tool once you've extracted data and see, was there any data points where the tool was less confident? So for those of you familiar with the field of AI, here's an explainability feature, right? Where the tool goes, I am super confident, as you can see here, when it comes to, experiment A1, there is a linked object of thickness of the steel sheet to begin with, and that is listed as 3 millimeter. And you can see here at the bottom, the confidence of the tool is 0.999999, etc., which means the tool is very confident it got this right. While there might be other areas where the tool is a lot less confident. So then you know that that's where you want to put your manual effort. And that's how you know that you can trust the tool, because it will tell you when it's less confident where something might go wrong, and you can go in and check that, which also gives you a lot of confidence in the data you've extracted. And then the question, of course, becomes how confident can we be? And how good is really the tool? And the fact is that machines excel where humans don't. The statistics of the tool right now is that you can do 60 patents in about 2 minutes. So you can do 1 full month of manual labor in 2 minutes. And this is close to 90% accuracy. We're getting closer to 90% accuracy right now at about 85% precision and recall. We can talk about those numbers more in detail if you want during the Q&A. But the tool is already better than humans. And plus, it will tell you where it's not confident, so you can go in and double check and spend your human power on the double checking. Not to go into too much technical detail, but the real magic and the real breakthrough, which we are the only ones in the world, as far as we know at this point, that have managed to do, is linking the values and the entities. And so what the machine does is that we feed it a number of different input data or a number of different pieces of knowledge. So the machine will look at, are there an exact, is there an exact match between this term we found here and terms in your output data? It's going to look for synonyms. It's going to look for contextual similarity in the text flow. It's going to query a knowledge graph where we're going to look at things like causality and compositionality and has this been found before? And it takes all of that information into account before assigning that specific value with that specific unit to the right location. Well, hopefully the right location. So that is where the real power of this lies. And as I said, we bring this self-assessment module into the mix as well, so that the humans can really build confidence in the results. One of the big questions, of course, when dealing with AI is, what does it actually take to get started? How much training is it? And here's what this looks like. So for the basic features, which is, it has to be within the broad chemistry domain. We sell it as a software as a service, which means you just subscribe to the tool and you pay per document successfully processed. English language documents, machine readable PDFs, data in text and tables only, because we're still working on the images. And this confidence score is, of course, part of it. All you need to get set up is a good description of the working field. So a good description of, let's say, the polymers that are your main focus, or the drugs or diseases you're working with on the pharma side, for example. You need a simple output data layout, and we're happy to advise on how to set that up, the layout that you want the data into. And then there's a simple feedback loop with expert validation, less than 4 hours of just validating that the first results were in fact correct. And then we have add-on modules like going beyond chemistry domain, etc. So it's a real simple few-day process of getting the tool set up, which is also very unique in an AI context. So with that, I am out of time and out of slides. I'm happy to answer any questions you might have. You're, of course, also very welcome to get in touch with me by phone or by email, and happy to connect after this presentation. So thank you so much, everyone.